Welcome to my short video on 7 frequently asked questions about low latency microservices in 7 minutes. My name is Peter Lawrey and I'm the CEO of Chronicle Software. The company provides products and consulting services for enabling technology in trading systems. Our clients include 8 of the top 11 investment banks, as well as exchanges, hedge funds, and crypto trading firms. We specialize in low latency, event-driven trading systems. Our solutions enable trading systems to achieve latencies in the low microsecond range across languages such as Java, C++, Rust, and Python. We balance flexibility with the performance you need. Chronicle Services has laid a great foundation for us to build our trading algorithms. They helped us design latency-sensitive, deterministic, testable components that we'll be using for years to come. How do latency expectations differ? In conventional microservices, latencies average around 1 millisecond for individual services and 100 milliseconds end-to-end. In low latency microservices, latencies are around 10 microseconds consistently for individual services and around 100 microseconds consistently end-to-end. For example, our fix engine consistently has a round trip of around 10 microseconds at a throughput of 100,000 messages per second. How does behavior-driven testing and determinism make a difference? Behavior-driven testing of deterministic systems improves developer productivity and simplifies testing, as well as failover in conventional microservices. These techniques make it easier to reason about your system and focus on the business requirements. To make it fast, first you need to make it work. For low-latency microservices, our Chronicle Services framework minimizes accidental complexity and makes performance testing trivially simple. How does dynamic scaling differ? Conventional microservices focus on horizontal scalability, where additional instances can be started up in seconds to handle increased load. Low latency microservices, however, are designed to run at 1 to 10% capacity, resulting in significant headroom, maintaining responsiveness and quick handling of short bursts of activity. A 1% utilization means that 1% of the time, your system is already processing an event when a new one arrives. Thus, the worst 1% latencies of your system are impacted by still processing the previous event. Do low latency systems use caching? Conventional microservices software cache reasonably used data, aiming for a high cache hit rate. For low latency systems, all necessary data must be in memory, with no need for additional data to be requested from an external source. This ensures consistent low latencies, particularly for the 99th percentile and above. Does low latency mean no allocations? A physical machine can allocate around 10 gigabytes per second. This limit is imposed by the memory bandwidth rather than the cost of garbage collection. In low latency microservices, however, we routinely achieved an allocation rate of less than 1 gigabyte per hour, with little impact on memory bandwidth and dramatically reducing the need for GC pauses. How are services deployed differently? Conventional microservices are typically deployed on systems in the same data center or region. The FastPass for low latency microservices ideally operate on the same physical machine, communicating via shared memory, even between Docker containers. This allows microservices to communicate at speeds comparable to threads in the same process. How is monitoring different? Conventional microservices record timestamps with a resolution of milliseconds, while low latency microservices require microsecond or nanosecond resolution timestamps to ensure precise performance tracking. Our microservices framework records nanosecond resolution timestamps for events in and out of every microservice. Now for an infrequently asked question. Why is Little's law important? Little's law is a fundamental theorem in queuing theory that relates the long-term average number of items in a queuing system, the long-term average effective arrival rate, and the average time an item spends in the system. More simply put, average concurrency you need is the average throughput times the average latency. However, In reality, you will need to add headroom to this. Consider a cluster of microservices that need to process an average of 10,000 events per second. If a cluster has an end-to-end latency of 100 milliseconds, it must handle at least 1,000 events simultaneously. During a surge, it might need to manage thousands of concurrent events. On the other hand, if a cluster has an end-to-end latency of 100 microseconds, it will only need to handle one event at any moment. During a surge, it might need to manage several events between the microservices. This lower concurrency requirement significantly simplifies the design, testing, and failover processes. Our philosophy is to go faster by doing less, focusing only on what is necessary. Build it fast, build it quickly, build it safely. And one of my favorite quotes is, "Perfection is achieved not when there's nothing more to add, but when there is nothing left to take away." I'll leave you with a quote from our largest client: "The way to build low-latency microservices." For more information on Chronicle Services, look at our website on chronicle.software/services, or for more technical articles in general, visit chronicle.software/learn.